Okay, today we're going to practice on daily lesson 180 and 181. So starting where we left off, we can do this. A lot of this is just practicing what you know now and making sure that you know it, like solidifying that understanding. So here we're going to talk about a pan of biscuits. Delicious. Maybe, unless they're gross biscuits, but I'm going to guess they're delicious biscuits. A pan of biscuits is removed from an oven, at which point at time t equals 0, the temperature of the biscuits is 100 degrees. So we know at time t equals 0, 100 degrees Celsius. The rate at which the temperature of the biscuits is changing is modeled by this function. So what I'm going to do is I'm actually going to just say b prime of t, and because I know I need to sketch it down here anyway. Oh, that's kind of hard to see. So in a calculator, if you don't have a calculator, pause this, go get one now. But negative 13.84, and then I'm going to say e, so second e, to the negative 0.173x. Okay, so mine looks just like theirs, except it has an x. So if I'm going to actually make my window the same as it is down here, because I'm going to have to do this in a second. So my y value, I'm going to go -6 to +2. So my y min is -6. My max is +2. My x min will be, sounds like X-Men. My x min, I'm going to put -1, and then my x max, I'm going to put 11. Okay, sounds good. I've got a graph. So if this asks me to find the value of b prime of 3, this is the graph. If we went back here, this is the graph of b prime. So when it asks you b prime of 3, do it. What do you think you do? We're going to do second, calculate the value, because this is just the function value at 3. Or you could go to the home screen and you could put in 3 anytime you saw a t. Now I get, put it over here, kind of hard to see sometimes, but I'll bring it back in a second. B prime of 3 is this value down here, so negative 8.236. And then we have to think about, what does that mean? Like, what units do I put on here? And it says, explain the meaning of this value in the context of the problem. So in this particular problem, at negative 8.236, the units for b prime would be, b is given in Celsius, the temperature is given in Celsius, but this is the rate at which the temperature is changing. So this would still be the rate at which the temperature is changing, and it says minutes up here, so I'm going to say degrees Celsius per minute. That would be an appropriate rate for these biscuits to change their temperature. So in here I'm going to say, if at 3 minutes, you always have to have a time, the temperature of the biscuits and let's finish the statement, is changing at a rate of negative 8.236 degrees Celsius per minute. I'm including units, I'm including the rate. If you wanted to say the rate at which the temperature of the biscuits is changing, that's okay. That's just semantics. I said that weird. But it's just okay to change the language a little bit. Just be careful that you're giving, you know that this is the rate that the temperature of the biscuits is changing. Okay, and I didn't say the temperature of the biscuits is decreasing at a rate of, because if I have decreasing and negative, it actually means they're getting warmer, which would be weird if they're removed from the oven. If we're sketching b prime of t, so b prime of t, and I know I've got this graph, I don't just want to kind of go, oop, there it is. There it is. That's funny. That's an old song. If I go second and then table, I can find some values on my graph. So I see 0, negative 13.8 something, so that's not on here yet. 1, nope, not there yet. 4 almost is. So 4 would be like negative 6.9, so almost 7. Let's pick another value. How about at 7. I've got negative 4.23, so somewhere around there. Let's go the whole way up to 11, negative 2.064. 11. Okay, so now I've got a couple points, and I could say, oh, it looks something like that. Explain in the context of this problem why this graph makes sense. So if I'm talking about b prime of t, so b prime of t, the first thing I noticed, it's always less than 0. Why is that? Remember what b prime is? The temperature of the biscuits is cooling out of the oven. Like, it doesn't make sense if the temperature was increasing. It wouldn't make sense because the temperatures or the biscuits are out of the oven. Also, what doesn't make sense is, let's say if the temperature of the biscuits, you get them out of the oven and it starts dropping, and then more and more and more and more until they're like frozen and then beyond frozen and something terrible. No, that doesn't happen. The temperature stops. The temperature of the biscuits will eventually become room temperature, and then it will stay there at room temperature. The biscuits, room temperature, everything will be the same. So it's not like they keep cooling until they're frozen. So down here, I can see the rate at which they're cooling is slowing down a little bit. So the rate is increasing. And the reason for this is when the biscuits, and I'm just going to say this in words, there's many ways that you can say this. Some of you who love physics, you'll probably say this slightly differently, but I'm going to say when the biscuits are pulled out of the oven, they are cooling at a much faster rate, meaning b prime of t would be more negative than after the biscuits have been out of the oven. Okay, so let's actually compare what you wrote and what I wrote. So when the biscuits are pulled out of the oven, they're cooling at a much faster rate. B prime of t is more negative than after the biscuits have been out of the oven for a while and are approaching room temperature. So this b prime of t is less than 0. The temperature of the biscuits is cooling out of the oven. I agree with that. But when they are pulled out of the oven, they're cooling at a much faster rate. So, or I can say immediately after biscuits are pulled out of the oven, they're cooling at a much faster rate than after they've been out for a while. Okay, at time t equals 10, what is the temperature of the biscuit? So the only thing we've been given so far is a rate, but now I want the temperature. So anytime you're thinking about that and you're like, if I'm given a rate and I want to find the temperature, I know I need to integrate. And now let's think about this, what it means. If this is at time t equals 10, I know I have to have 10 somewhere on either my lower limit or upper limit of integration. I'm putting in the upper just because I know what the lower will be. I'm going to direct you up here. At time t equals 0, we know that the biscuits are 100 degrees Celsius. So if I integrate to get the amount of change in the biscuit temperature from 0 to 10, and I know already fundamental theorem of calculus applies, and I know that the temperature of the biscuits at time t equals 0 was 100 degrees Celsius. Once I figure out this, that means that I can solve for b of 10 pretty easily. I'm going to do this a different way instead of using Math 9, which you could still use. Since I already have this graphed, I'm going to say second, calculate, and I'm doing the integral, so number 7. When it says lower limit, I'm going to put in 0. My upper limit was 10. What? Area under the curve, and it's below the x-axis, so I know the answer will be negative, because the change in temperature, the amount of change will be negative. They're cooling. So I say negative 65.81725. Solve for b of 10, so I'm going to go back to my, here I've got negative 65.81725 plus 100. And I find the temperature of the biscuits is 34.18275, or you could have put 34.183, and this will be degrees Celsius. Okay, let's practice one more. This one I want you to do even more on your own than maybe you did this time. So whatever you did last time, do a little bit more on your own this time. We're on page 181. A cylindrical can of radius 10 millimeters is used to measure rainfall in Stormville. Okay, so I've got a cylindrical can with a radius of 10 millimeters. So I'm just cylindrical can, 10 millimeters. Okay, got that in my head. I'm in Stormville. During the first 5 days of the month, 3 millimeters of rainfall have been collected. So in Stormville, 3 millimeters of rainfall have been collected during the first 5 days of the month. Okay, so that seems like important information. I should keep this in mind. This one, the height of the water in the can is modeled by this function S. Okay, S of t is measured in millimeters and t is measured in days from 0 to 60. The rate at which the water is rising is given by this. So we're given a derivative. We have to get back to S in some way. Okay, so let's do this. So the first one is really just a calculator problem. You can do this on, if you have a TI-84 or higher, you can do this on Math 9. If you have a TI-83, you will need to graph this and then do second, calculate, and then go down to integral like we did on the last problem. So I'm going to switch it up and go this way. I'm going to say Math 9. And you should too. Okay, so stop. Try to find what is this value from 10 to 15. Okay, check with me. Did you get this integral from 10 to 15 would be equal to 11.159. And we can keep going in case we use this later. 292 was the rest of this, in case we use it later, but this is how much we have right now. We've got this integral, and we've got this. We're like, okay, what does this mean? Well, remember that this, if I use the fundamental theorem of calculus, would mean S of 15 minus S of 0. Or 10, sorry. S of 15 minus S of 10, because 15 minus 10. What was S again? S of t is measured in millimeters. So we know that this is going to be millimeters. And this would be the change. So the amount of change and I can say of rainfall collected from 10 to 15. Let's think about 10 to 15 what? 10 to 15 days. Is 11.159 millimeters. Huzzah! Okay, at the end of the 60-day period, how much water had accumulated in the can? So let's think about this. We've got to find something we know. So if we're talking about the water that accumulated, what would that be? S of t or S prime? It's going to be S of t, and we find that using the integral of S prime. I know it's the end of 60-day period, so 60 is going to be up here, but I have to think, what do I put down here? This says during the first 5 days of the month, 3 millimeters have been collected. This is where we get to use that. So I'm going to say that's equal to S of 60 minus S of 5. Because we don't actually know from 0 to 60, we wouldn't be able to figure that out because we didn't know how much was in there to start. But we did know that from 0 to 5 that, what is it, 3 millimeters have been collected. So over here, I'm going to use this that I used before. I'm just going to go highlight that. And I'm going to rewrite over here from 5 to 60. And I get 163.5648782. I really don't need that many because I'm just going to add 3 to this. And here's where I can say, well, S of 60 actually is going to be 166.564. Or you could say 166.565. You do not have to say both. You can just say one of them. I'm just saying both, so you know you can either round this or you can truncate it. Make sure that we know at S of 60, how much is there? This is how many millimeters. At the end of the 60-day period, how much had accumulated. We set our answer. Show your work. We did. Yay! Okay, let's do one more. So really try to do this one on your own as much as you possibly can. The rate at which people enter an auditorium for a concert is modeled by this function R, given by R of t is equal to blah, 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 blah. So this is already a rate, even though it doesn't have prime on here. So be careful. This is the rate at which people are entering, even though this is measured as R, but not R prime. So sometimes that will happen, and that's okay. R of t is measured in people per hour. So the rate. VIP, very important persons, tickets were sold to 100 people who were already in the auditorium when the doors opened at time t equals 0. Okay, so let's actually just name some of these together. What is something that we could name as far as if R of t is the rate that people are entering? How about P of t is the number of people? Just so we can all have the same thing. So right now I know P of 0 is already 100. There's already people in there. The doors close for the concert and the concert begins at t equals 2. If all the VIP ticket holders stayed for this start of the concert, how many people are in the auditorium when the concert begins? Okay, so think of how you would do this. You're given a rate of people. Just try. I'm going to see at the very end, you're going to compare your answer with mine. If you need to follow through with me, you can, of course. But if not, try it now. Meet me at the next stopping point. Okay, so if you're still with me, or if you came back, I would say the integral of R of t dt. This is going to say this was the rate people were entering. So if I do the integral, it's going to be the amount of change in people. And I'm going to say from 0 to 2. Because this would allow me to find P of 2 minus P of 0. If P is the number of people. From 0 to R of t. This one we actually could do without our calculator too. You could add 1 to this, divide by my new exponent, add 1 to this, divide by my new exponent, do 0 to 2. So actually let's just do that. This would be 1380 divided by 3. Ugh, this could be gross real quick though. And then I would want to evaluate this from so I could put in 2 here. 2 cubed is 8. This seems awful anyway, because I would do 1380 times 8 divided by 3 minus 674 divided by 4 times 2 to the 4th. What is 2 to the 4th? The 2 times 4, 8. 2 to the 4th is 64. I'm just going to put it in here to be safe, and then I'll check myself afterwards. Ooh, so all of this we got 984 minus 0. I used my calculator anyway, so really I could have just done this in the first place. By the way, 2 to the 4th is 16. What was I thinking of? I don't even know. Yeah, because that would make that 2 times 2 is 4, times 2 is 8, times 2 is 16. Silly me. Whatever, it happens. Because I used my calculator anyway on this, you could have just done math 9, the integral from 0 to 2, 1380 x squared minus 675 x cubed hold on, why did I get 980 here but I got 984 there? Let me check. I'm gonna guess I made something. Hold on. When I did this, I did 1380 times 8 divided by 3. I'm gonna do that one again. What did I write? 674 instead of 675? Oh, I don't know what I did differently. Okay, so if I were to do it this way, I would do, this should be 980. Whew. Okay, and this is why it's also really helpful to just put it in your calculator when you have the opportunity. So I get 980 minus 0. On the other side, P of 2 is what I don't know. I don't know how many people are in there too, but I do know at 0 that there were 100 people. If I add this, the number of people at time 2. If they stayed, how many people are in the auditorium? This would be, there are 1,080 people. In the auditorium when the concert begins. Okay, so P of 2 is equal to 1,080, and we did this because we integrated the rate to find the amount of change in the number of people. We knew that there were 100 people there originally. You could do this by hand, but be careful doing so because I messed this up too, and you end up using a calculator anyway. So you could just put it in your calculator with R of T in here and integrate from 0 to 2. Thanks so much for being great. I think you're awesome. Please let me know if you have any questions at all. Thanks for working. Bye.